Assalamualaikum warahmatullahi wabarakatuh, and this is our group member for subject electronic communication system. We are from group 6 section 2. So our leader is Muhammad FAIZ bin ZAINOL bin ABIDIN, matrix number DE210014, Muhammad SHAHRIL AMIN bin SHAHNON, CE210040, SEERKAMBAN anak lelaki ELANGOVADIKAL, number matrix AE210073, INTAN SYAFIQAH binti SYUKRI AFENDI, AE210021. And lastly, which is me, RAIMI NADIRAH binti BAHAROM, AE210040. I'm going to present for the introduction. AM transmitter is one of the earliest modulations for radio data transmission. It is developed during radio telephone experiments in the early 20th century by Landel de Mora and Reginald Fessenden. The modulation technique evolved through the several successful trials and became a cornerstone in electric communication. The principle of AM is amplitude of the carrier wave varies in accordance with the modulating signal or data, and it is fundamental for radio data transmission. And for the project background, we need to design and construct an AM transmitter for a public radio station. Next is filler table. For the fact, it is essential for developing an AM transmitter with a 1 kilometer area of coverage for a community radio station. Next is the idea. Need to produce a wave that can carry the information from our AM transmitter to another radio with the span of 1 kilometer. Learning issue, it has two, which is how to produce a wave that transmit by AM transmitter. Second is how is the AM transmitter. For the action plan, we need to find some information on the internet or read some reference books about AM transmission. Next, for another learning issues is how to build an AM transmitter that produces a wave that can propagate an amplitude to travel across a one distance. What is the cost to design and build an AM transmitting circuit? For the action plans, we need to ask in the lecturers or someone who is an expert at amateur radio for guidance in designing and building an AM transmitter. Second one, can research on the subject of AM transmitter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amin bin SHAHNON. So I will present for my part. So this is circuit simulation that I create by using Proteus. In this circuit, we using 7 resistors and capacitors. Both component using different values, and then we also use microphone, and then for next is circuit description. Okay, circuit description. One shot and stable are the two primary operating mode for 5/5 timer. So we the function of 555 is similar to a monostable multivibrator in one-shot mode. One stable state, known as the off state, exists for a monostable. The monostable circuit receives an input trigger pulse. It produces a single pulse that lasts a predetermined amount of time. Next is system description. So this system description is 5/5 timer. So we use 5/5 timer is because to its delay, then the output that we will get is square wave like this. Then next is system description NE5532. So NE5532, it has 8 pin 8 pin out. First is output A, second pin is inverting input A, third pin is non-inverting input A, 4 pin is negative voltage, 5 pin is inverting input B, 6 pin is non-inverting input B, 7 pin is output B, and last pin is 8 is positive voltage. So last is an E5532 description. Dual high performance operation amplifier. We own for its exceptional low noise, minimal distortion, and characteristically warm sound. The NE5532 boasts impressive technical specifications that contributes to its exceptional audio performance, capable of delivering up to 35 milliampere of output current. The NE5532 can directly drive speakers and other audio equipment without requiring additional amplifier. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAIZ bin ZAINOL ABIDIN. My metric number is DE210014. So today I will be presenting about final output analysis and discussion. So for the final output analysis, this is our output, which is our antenna. We put the oscilloscope at our antenna. So as you can see, it doesn't really differ from the frequency carrier, which is also square wave. Only the difference at the frequency level, which is 607 kHz at the antenna. Previously is 625 kHz at the frequency carrier. And then, so for the frequency spectrum, it is 650 kHz, the cursor at the 650 kHz, and our frequency is 645 kHz. So our spectrum is actually at the left side, as you can see the cursor there. And then for the discussion about this AM transmitter, it used a square wave as a carrier modulation technique. It doesn't really modulate the amplitude. The timer cannot amplitude modulate, so it used the square wave carrier modulation technique. So the audio input from the audio jack modulates the amplitude of a square wave generated by the LM555 timer. So the audio jack will modulate with the square wave at the pin number 5, which is control voltage, and then it will amplitude modulate there using the square wave carrier modulation technique. It's not the same as the amplitude modulation technique, but it can work as a AM transmitter because its frequency range is 500 kHz to 1600 kHz, so it can work well as a AM transmitter. So the modulated signal is then amplified and then transmitted through the antenna, and then the square wave from the LMC 555 acts as a carrier wave, and then amplitude modulated into audio signal from the audio jack. So the carrier is from the timer, and then from the audio jack it will go through the NJM 5532D, and then it will go to the control voltage pin, and then through the output pin, which is the pin number 3, we put antenna there. So that's how our circuits works. So from the audio jack we'll go to the NJM, and then we'll go to the control voltage pin number 5, and then to output number 3, and then through the antenna, and then it will transmit the signal through the radio. Okay, so for the signal analysis, the audio jack picks up the sound waves and converts them all into AC voltage varying amplitude and frequency. So the typical range is between the human hearing, which is 20 Hz to 20 kHz. So for the modulated signal, the square wave from the 555X as the carrier signal, which is amplitude varying according to the audio input. So due to the square wave modulation, the modulated signal has sharp transition between high and low. It's nothing smooth like the sine wave in traditional AM transmitter. So as you can see, the 555 timer is not really use the amplitude modulated technique, even though it is a AM transmitter. So for the output signal, the amplified modulated signal is transmitted through the antenna as an RF signal with the same carrier frequency as the square wave, but with varying amplitude due to the modulation. The bandwidth is wider than the input signal due to the presence of sideband space at multiples of the audio frequency. I think that's all from me. Thank you very much.
Hello everyone, my name is SEERKAMBAN Anak Lelaki ELANGOVADIKAL, matrix number AE210073. And today I will present the part A and part B of the input and output analysis. So for part A, input analysis, figure 5 shows that at first we used the electric microphone that has no changes in input. So we decided to change it into an audio jack. So in the second picture, figure 6, this is the input from the audio jack that we used that is shown the peak-to-peak voltage. So for part B is the subsystem output analysis. So for 1, figure 7 shows the capacitance voltage that we got in our 555 timer. The peak-to-peak voltage we supply is 9 volts. With a little bit over voltage drop, we get 8.86 volts. And the waveform is dropped at the end of the peak because of the discharge of the capacitor. So for 2 is carrier frequency. The figure shows the output signal of the AM transmitter that has been recorded using an oscilloscope. From the signal above, we can see that the output signal is form of a square waveform. The frequency of the output is of the signal is produced by the AM transmitter is 625.87 kilohertz, meaning the frequency of the output signal is within the AM frequency. The peak-to-peak voltage of the output signal, VPK, is 840 millivolts. Unfortunately, the 555 timer cannot really amplitude the modulation. If we want to modulate the signal, we need to use the help of a function generator. Because of the nature of the 555 timer is square wave, and the square wave will act as a carrier that difference the relationship between the frequency and time, thus will help to carry the message to the output. That is all from me. Thank you very much.
For the conclusion part, this project is not only remain rigorous adherence to regulatory requirements, but also necessitated a profound commitment to delivering high quality audio transmission. This project was paramount important in its humanizing aspect of empowering future and engineers to bridge the gap between theoretical knowledge and hands-on expertise. In a broader context, the advantages of this project are multifaceted. It's collective and environment where students are not merely passive recipients of information, but active contributors to the environmental landscape of art and engineering. So, with the development of an transmitter of 1 kilometer coverage vector, ensure that the fruit of this vector resonate within the community, fostering connectivity, information dissemination, and cultural exchange. It is a testimony of the transformative potential engineering education and company area world advantage. The skill honed through this endeavor will not only shape the trajectory of our career, but also contribute a meaningful to the fabric of societal communication and connectivity. So, this is our reference that we got from the PPT, which is we have 1, 2, 3, 4, 5, so for the black we have 5, 6, 7, 8 process from the PPT that we have section. And also the requirement in the report section. So for the embedded unit of 15, So this is minute of meeting 1. You can see this is the minute of 2. This is minute of meeting 1. This two, and this is minute of meeting 2. This of minute of meeting 3. This of minute of meeting 4. This of minute of meeting 5. And also plus this is minute of meeting 6. So that's all from me. Ada reference